Oscillating dipole also produces electromagnetic waves. Oscillating dipole. What is the meaning of oscillations? Oscillating dipole. What is this dipole here? Dipole is nothing but two charges plus q and minus q are placed apart from each other at the length L. At the length capital L is equal to 2L, 2 times of small l. This to this length is L, and here to here also length is L. This is the center point. So this electrostatic dipole also produces electromagnetic waves when this dipole oscillates. Oscillations means this charge is coming sometimes here, plus q here, minus q here. It is rotation. Okay, rotation of a dipole also produces electromagnetic waves. Oscillating dipole is the next reason. Two reasons: accelerated charge particles, and the oscillating dipole. These are the two reasons that electromagnetic waves are created. What is the curve of this electromagnetic waves? Electromagnetic waves, these two waves are perpendicular to each other. Electric field is always perpendicular to the magnetic field. Electric field is always perpendicular to the magnetic field. Here the idea of displacement current comes. And magnetic field simultaneously. When these both fields are placed together, electromagnetic waves are generated. EMW. In short, we write EMW. So, on first overview of this topic of displacement current is how displacement current is produced. You know what is the meaning of current? Rate of flow of charges. Displacement current means how current is displaced. There are two types of current here we have to study. One is conducting current, and the another one is displacement current. What is the meaning of this displacement current? It is simply represented by ID. Okay. Displacement current is represented by ID. And what is the formula of current? Rate of flow of charges. Current is nothing but rate of flow of charges. It is dq by dt. Since we know ID is equal to rate of flow of charges, so dq by dt. Next we are on to our next step. We are on our new procedure. So ID is equal to what we have? dq by dt. From the Gauss law of electrostatics. Do you know the Gauss law of electrostatics? What Gauss law of electrostatics explains? It explains that the total electric flux, say phi E is equal to 1 by epsilon naught times charge enclosed. 1 by epsilon naught times the total charge enclosed. So on substituting it here, okay, placing epsilon naught here, value of Q enclosed is equal to phi E times epsilon naught. Understand? From Gauss theorem we know that phi E is equal to 1 by epsilon naught times Q enclosed. So the value of Q is phi E epsilon naught. Put in this equation number first, substitute the value of Q from equation number second. So the value of ID is equal to d phi E times epsilon naught, derivative with respect to time. So this epsilon naught is nothing but it is a constant quantity, so it will be coming outside. Epsilon naught is equal to a constant, permittivity constant, so it will be coming outside. Okay, so ID is equal to displacement current is equal to epsilon naught times the flux, total electric flux through a region. That's the formula and expression for displacement current. Displacement current. So we'll use this formula and expression to expand and explore more about our new topics of electromagnetic waves. Electromagnetic waves. So the displacement current, the value of displacement current is this one. We will take this value and we will move on to our next topic, the total current. Okay, the total current. Since the total current is the sum of conduction as well as displacement current through an electromagnetic wave, the total current is conduction plus I displacement. The total current is I conduction plus I displacement, on new concept. At a time IC is equal to 0, when the IC is equal to 0, conduction current is 0, the total current is equal to the total current is equal to the displacement current. The total current is equal to the displacement current. When the conduction current is 0, conduction current, when the conduction current is 0, the displacement current is numerically equal to the total current in terms of an electromagnetic waves, EMW, not BMW. These expressions are clear. These expressions are clear. So I is equal to IC plus epsilon naught times d phi E by dt. That's our expression. When IC is equal to 0, it is numerically equal to the displacement current. Put IC is equal to 0, we will get epsilon naught times d phi E by dt. Rate of change of electric flux. Rate of change of electric flux. What is electric flux?